Okay, we're going to find the length of an arc that subtends a central angle of 288 degrees in a circle of radius 12 feet. So we need a formula to get through this problem. And the formula we want is S equals R times theta. All right, so let's talk about the components of this. S means the distance around the outside of this circle. So like this distance all the way around here is going to be S, and that's going to be in feet because our radius was in feet as well. It subtends a central angle of 288 degrees. So that means if we rotate all the way around here, theta equals 288 degrees. Now that's a little bit of a problem that theta is in degrees. And I only say that because for this formula to work right, theta needs to be in radians. And that's what a lot of students overlook. So we're going to have to do a little bit of work to switch theta over from degrees to radians first. And then radius r is going to be 12 feet. That's the distance from the middle of the circle to all these points on the outside. So we're given that r is going to be 12 feet. We'll put that in. All right, so our first goal is we can't deal with degrees. We got to go over to radians. So let's convert over from theta being 288 degrees. We're going to use a conversion factor. We're going to treat it as though it's in the numerator right now, and we're going to multiply by something that connects together radians and degrees. So we want to end up with radians, so we'll put that in the numerator. We want to get rid of our degrees, so we'll put that in the denominator. And hopefully we know that pi radians is equivalent to 180 degrees. And why we lined it up in this direction is we want degrees in the numerator to cancel out with degrees in the denominator. From here, a little bit of simplifying down. We'll multiply numerators, multiply denominators. So we do end up with 288 pi over 180, and then our units are going to be in radians. We can reduce this down a little bit if we want to. I believe that 288 and 180 are both multiples of 36. And don't worry if you're like, how did he come up with that? It was just a little bit of work. Reduce down as you can until you get to 8/5 radians. All right, so we've rewritten our theta. It's in radians, and we have our radius given to us. So now let's plug into our formula. S, the distance around the outside, is going to be our radius, 12, multiplied by our radian measure theta, so 8 pi over 5. And now we'll treat the 12 as though it's in the numerator, and we'll multiply numerators together and denominators together. And we're going to get 96 pi over 5, and this is going to be in feet for our units. Now, if we wanted to reduce this down and get an approximation to go along with this, to be clear, we just found an exact answer, and we like exact answers, but if you wanted to get an approximation, you'd put it in the calculator and get about 60.319 feet. Sometimes in practical applications, getting approximations makes a whole lot more sense. If you were actually building, say, a retaining wall or something like that, and you had to go to the store, it makes more sense to say I need just over 60 feet of material instead of 96 pi over 5 feet. All right, hope this helped you out. Make sure that when you're doing these, if theta is given to you in degrees, you got to make sure it goes over to radians first before you plug into our formula. All right, good luck to you with figuring these out.